Alright then, so now we've covered a lot of the basics, we can start to dive deeper into a few different topics and really get to see the benefits of TypeScript shine through. So in this chapter, I want to just talk a little bit more about interfaces and type aliases, just to lay the groundwork for the next chapter really, where we're going to make a mini project that uses both of these things. So then, just as a quick reminder, interfaces are a way to define a data structure that values which implement that interface have to adhere to. For example, I've got an interface already defined here called hasQuantity, which says anything that implements this interface must have this quantity property, which is a number. Now then, if I wanted to make a new object literal and type it as this interface, then I'd have to say something like const, then something, then a colon, and then set it equal to an object, right? And this object structure has to match the exact structure of the interface. So it can only have that one single property quantity, which is a number. If I try adding other properties onto it, like a title or something, then I'm going to get an error. It's not going to let me do that. So when you're typing something like this explicitly using an interface, it has to match that interface structure exactly. Now, another way that we'd use an interface is within a function to specify the type of an argument. And this is where the behavior of interfaces can get a little bit murky and confusing. So let me just quickly paste in a function and then explain what this does. Okay, so we have this function now called printQuantity, which takes in an argument called items, which we're saying has to adhere to this hasQuantity interface. The function itself doesn't return a value, which is why we say void here. So then TypeScript knows that because we've specified this hasQuantity interface as the argument type here, that the item argument definitely has to have the quantity property, right? And it will have that quantity property within this function. So if I type item and then a dot, I can see that the quantity property is an option. And that's the only property TypeScript knows for sure that this item has, because it's the only property defined in the interface. So what I'm going to do is just quickly log that property out inside this function by saying console.log, and then a template string so that we can output a dynamic variable. And then we'll say the quantity of the item is, and to output the variable inside the template string, we need the $, curly braces, then the value itself, which is item.quantity. Alright. So we have this function set up now, and now we can try using it by passing some different values into it. So what I'm going to do now is paste in a few objects that I've already created. We've got one called fruit, which has a name and a quantity. We've got one called vehicle, which has a type and a quantity. And we've got one called person, which has a name and an age. So we can see that the first two objects both share this quantity property, which is a number. But they also have other properties, a name and a type. The third object is just completely random, and it doesn't have the quantity property, it just has a name and an age. Now, what's going to happen when we try to pass these objects as arguments into the printQuantity function? Well, let's try it out and see if we get any errors. So, let's say printQuantity down here, and first of all, we'll pass in the fruit constant, the fruit object. And when we do that, we can see we get no errors. For the second one, we can say printQuantity again. And this time we can pass in the vehicle object. And again, when we do that, we should get no errors, which is awesome. And then finally, we invoke the function again, printQuantity. And then now let's pass in the person object. And when we do that, we're going to see that we do get an error. So let's just quickly talk about what's going on here. So when we create a variable that adheres to a given interface, and by that I mean that it includes all the properties in that interface and has the correct type value for those properties, then we can use that variable as an implementation of that interface, even if it has extra properties which aren't inside the interface. As long as it ticks all the interface boxes, it can be considered a kind of implementation of it. And therefore, we can use that as an argument to the function, because TypeScript knows that this variable we created ahead of time has that quantity property. It conforms to the interface type we specify as the argument. So that's why we can pass those two variables in as arguments, because they both have the quantity property outlined by the interface. When we try to pass in the person object, TypeScript knows this doesn't conform to the hasQuantity interface because it doesn't have the quantity property, and therefore we get an error. So when we create a variable ahead of time, like this, which adheres to an interface, even if it has extra properties not on the interface, it can be seen as kind of an implementation of the interface. It satisfies the requirements of it. And therefore, we can use that variable as an argument which has that interface type in a function. Okay, all good so far, but there is an edge case where things don't work as you would expect. And I want to mention that so that you don't get caught off guard by it. So then what if I invoke the function again, and this time I try passing in an object literal as an argument directly into the function call. And this object is going to have that quantity property. So this is going to work because this is exactly the same type of object as described in the interface. But what if I now add another property, like title for example, which is a string value? Well, then when we do that, we get an error. And that error says that this object literal is not assignable to the type hasQuantity. So that's strange. It worked when we had extra properties in the variables that we made ahead of time, but not when we directly create the object in the function call. And that's something you need to be aware of. When we make the variables ahead of time, either this way or by using a class to make a new object, which we'll see later on, then it's going to work. It's going to allow us to do that. Those objects can have extra properties not defined in the interface when we're using them as arguments. But when we create an object literal within the function call directly, it behaves the same way as if we were making a new variable which has that hasQuantity type. It's almost like we're doing this under the hood where we're explicitly typing the value to be the interface type right here. And therefore, we can't add on those extra properties. Anyway, we're going to see this approach a little bit as we move forwards, where objects are created ahead of time which might have extra properties, and we can share and reuse the same interface then with different objects. Okay, now my friends, so the next little thing I'd like to talk about is something called a function signature. And a function signature is basically something which describes the general structure of a type of function. And by that, I mean it describes what argument types it should accept and what type of value it returns. It's almost like a way to give a function a specific type itself. I think the easiest way to show you this is by jumping straight into an example. So I'm going to create a new type alias called calculator, and I'm going to set that equal to what will eventually be a function signature, which describes a function that could be seen as some kind of calculator function. Alright, so the way we make a function signature is in two parts. The first part is to describe the arguments. The second is to define the return type. So first of all, the arguments, to do that, we open the parentheses and just list them out as we normally would. So for example, I could say that this function needs a first argument, which I'm going to call num1, which is going to be a number. And it also needs a second argument, which I'll call num2, which is also going to be a number, right? So we've defined the arguments now, and now we just need to specify the return type, and we can do that as we would in an arrow function using an arrow, then the type, which is going to be a number in our case. And that's it. That's our function signature created, and we're storing that as a type alias called calculator. Alright then. So what I'm going to do now is paste in a few functions, one at a time, and we're going to go through each one to decide whether it matches this calculator function signature. Okay, so let me just paste in the first one right here. So we've got a function called add2numbers. We're taking two arguments, a and b, and they're both numbers. Now we don't explicitly say what the return type is, but you can see down here we return a plus b. So do you think this is going to conform to this function signature? Is it of a type calculator basically? Well, yeah, it is, because we're taking two arguments, a and b, which are both numbers. And by the way, they don't have to be called the same as num1 and num2. The argument names can be different. What matters is we're taking in the correct type for those arguments. Okay? So this bit is fine. And then we are returning a number because a number plus a number is a number. Even though we don't explicitly say right here we're returning a number, TypeScript infers that we are returning a number because we're returning the sum of these two things right here. Okay, so that one is essentially of type calculator. Let's paste in another one. So this time we have a function called multiply two numbers. Again, we take in two arguments, first and second, and they're both numbers. So this part is fine, even though again, these are different names, it doesn't matter. Then down here, we return first multiplied by second. So number times a number, and again, TypeScript is going to infer the type returned by this function to be a number, even though we don't explicitly type it. So it might choose this thing right here, the return type. So again, this would effectively be of type calculator if we wanted it to be. Alright, so I'm going to paste in two functions this time. Down here, we've got square number, and then we've got join two numbers. So square number right here takes in one argument, which is a number, and it returns that number times by itself. So it is going to return a number. However, we only have one argument. We don't have two. Now we're going to come back to this in a second. Then we have join two numbers, which takes in num1 and num2, which is like this, which are number and number. And then we return a template string, which is num1, then num2. So these two here, do you think that any of these two are going to kind of conform to this function signature? Well, let's find out. What I'm going to do is create a new variable called calcs. And I'm going to type that to be an array. And the type of objects in this array, or the type of functions rather, in this array are going to be the calculator ones. So basically I'm saying this can be an array of functions, right? And the functions inside that array must match this calculator function signature, because we said calculate array. So if I wanted to push these two into that array right here, then we know it should work because both of those match this function signature. So let me demonstrate that. I'm going to say counts.push, and then it would be add two numbers. That was the first function. And why is this not working? Oh, because we need to set this equal to an empty array to begin with. So we have an empty array. Then we're saying push add two numbers, this function, to the array. There's no errors. That works because this right here, this function matches this calculator function signature. Let's try the second one, calcs.push, and then it's multiply two numbers. That works as well. Okay, so down to the third one down here. In fact, you know what I'm going to do? I'm going to come back to that one. This one here, join two numbers. Let's try that. Calcs.push, and it's going to be join two numbers. Now, do you think this is going to be allowed? Well, we're returning a template string. And this says return a number. So technically speaking, we're not returning, the correct type right here. Even though we're returning num1 next to num2, it's not the correct type. So if we try to add that one, join, we can spell correctly, join two numbers, then we get an error. And it says argument of type, and then this function signature, which matches this function we created, where we return a string, which is what we're returning right here, is not assignable to a parameter of type calculator. Type string is not assignable to type number. So it's saying that this string right here we return here is not the same as this where we say number. So we can't do that. Okay, so the final one, let's say calcs.push, and then it's square number. Now, do you think this is going to be allowed? Remember this one with one argument? Well, let's see, square number, and there's no error. Why is that? Well, when we create a function signature, in order for a function to adhere to that function signature, it doesn't have to have any or all of the arguments. It can't have more arguments. So if there were 3 arguments inside this function, then it wouldn't work. But if there was only 1 argument or even no arguments, then it would still match that function signature as long as it returned a number at the end of it. And the arguments right here just wouldn't be used essentially. Okay? So it still matches right here, even though we have just 1 argument. If we have 0 arguments, like I said, and we return a number 5, it's still going to adhere to this function signature. So these are kind of optional, these things right here, but we can't add more. So I couldn't have 3 arguments right here. Alright, cool. So that's the basics of function signatures. Now let's have a look at how we can use function signatures on interfaces. So what I'm going to do is create an interface, and it's going to be called hasArea. Now this interface is going to say we need a name property, which will be a string. And then also it's going to have a function. So we've seen properties on interfaces in the past, but this time we're saying any object which implements this interface must also have a property which is a function. And we're going to call that calc area. Okay. So this right here is going to be a function signature, much like we created one up here. So we need the arguments and then the return type. So calc area is going to take in an argument, which we'll call a, and that's going to be a number, and then it will return a number. Okay? So then, let us now try using this. I'm going to say const shape 1 is equal to, in fact, we'll type it first. We'll say has area. So it needs to implement that interface. And then we're going to set that equal to an object. So we need the name property, which is a string, and we'll say square for this one. And then we also need a calc area function, which returns a number. So I'm going to take in maybe the length. So the length would be a number, right? Like so. And then right here, all we need to do is return L times L, because that's how you work out the area of a square. You take the length and times it by itself. And when it's a square, the length and width are the same, right? So it's basically just the square of the length. Okay, so now we could use that. If we wanted to, we could say, for example, shape1 dot calc area and then pass in a number, and it's going to give us a number back. All right then, so let's do another example. I'm going to say const shape2, and we'll type it to be has area. Set it equal to an object. The name this time is going to be circle. And then we also need a function. So calc area. And this time we're going to take in at the radius, because this is how we work out the area of a circle, right? Using the radius. It needs to be a number. And then it needs to return a number. So let's return. And it's pi r squared. So math.pi times r. It's the power of 2. Right? Is that right? Let's correct it if we don't need these parentheses. I don't know why I've added those on. So math.pi times r to the power of 2. So both of these functions right here, they match this function signature, even though they're different functions. Alright, so I could say, like I said, shape1 dot calc area and pass in 5, and that would give us a number back. 5 times 5, which is 25. I could do shape2 dot calc area and pass in 10 for the circle, and it's going to work out the area of the circle based on that radius. Awesome. Now, this right here, this looks the same as this, right? A bit like an arrow function, but you can write these function signatures a little bit differently as well when we're using them as properties. So I could just remove that column and then straight away have the parentheses, and then instead of an arrow, I could use a column. And this does exactly the same thing. It's a function signature, basically, inside an interface. Alright, so that's function signatures. We will probably see them a fair amount as we go through the rest of the course. Alright then gang, so now I want to talk about how interfaces can be extended to create new interfaces. If you've ever worked with classes in JavaScript or another programming language before, then the idea is a little bit like one class inheriting properties from another class. In interface terminology though, we say that an interface can extend another interface. So let's jump right into an example. So I'm going to create a new interface called hasFormatter. And inside here, I'm just going to specify that we need one property, which is a function, and that function should return a string. So this is a function signature like we saw in the last lesson. We're saying anything that implements this interface must have this format method, which returns a string. So now what I'm going to do is create a new interface which extends this one. So let's say interface, we're going to call this one Bill, as in a tab, not the name Bill. And this is going to extend, so we say extends hasFormatter. Now what does that mean? Well, it means that any properties defined inside this interface, Bill, will inherit automatically. And we don't need to specify them again down here, but if we were to make a new object of type Bill, then it must also have this format one, this format method, even though we're not going to type it down here because we extend it. Alright, so it is going to have a few more properties. It's going to have an ID, which is a string or a number as a union type. And then after that, we're going to have an amount. and that's going to be a number. So that's the total of the bill. And then finally, we'll say maybe a server, and that's going to be a string. It could be the name of the person serving you. All right, so now let's create a new object. We'll say const user is equal to an object. And this is going to have an ID of 1. And also, it's going to have a format method, which returns a string. And in here, we will say return, and then a template string. This user has an ID of, and then we'll output the variable by saying this dot ID. So this refers to this object and then the ID property. Okay. Now, does this adhere to has formatter? Well, yeah, really it does, because we have this format function, but it doesn't adhere to this one right here, because although we have an ID, we don't have an amount or a server. However, we can make a bill. So let's say const bill and set that equal to an object. And then inside here, we'll say ID is going to be 2. And then the amount is going to be 50, a number. The server is a string, which is going to be Mario. Then we also need a format method. So let's do that. It's going to return a string. And then inside here, we'll say return template string. And we'll say bill with ID, and then output the ID. So $ curly braces, this dot ID has, and we'll say a £sign first of all, then $ curly braces to output a variable, this dot amount to pay. Alright then. So this right here really conforms to this bill interface because it has the ID, the amount, and the server, as well as the format method that we declare right here. And since bill extends has formatter, anything that is of type bill must have that format method, which this does. Awesome. Alright, so now what I'm going to do is create a couple of functions which accept arguments of these different types right here. So let's come down here, and I'm going to do the first one, say function print formatted. And then inside here, we're going to take a value, and that value must be of type has formatter. Alright, so it's not going to return a value, so I'm just going to say void right here. And then inside the function, all I'm going to do is say console.log. And then we'll take the value and call that format method on it, which returns a string, remember. So then, let's see if I can use this. I'm going to say print formatted. And then I'm going to pass in the user first of all. See if that works. So user. And yeah, we don't get any errors, and we don't get any errors because the user right here has that format method. Let's try the bill one. So print formatted and pass in the bill. And again, no errors. That works. Alright, so let me do another function this time. So function, and this time we will call it print bill. And we'll take in an argument called bill, which will be of type bill, the other interface we created. Again, return type is void, and inside the function, I'm going to log out to the console a few things, so console.log. I'll say the server first of all, which is bill, dot, and you see we get access to these different properties, and function, the format one right here, because it knows this is of type bill. So let's say dot server, and then after that we'll say console.log underneath, and we'll say bill.format. Well, like so. Now let's try this one. So I'm going to say print bill, and I'm going to try and pass in the user. Now obviously now we're going to get an error because user does not adhere to the bill interface, because the user only has the ID and format properties, whereas a bill requires amount and server as well. So that doesn't work. So let's comment this one out. Let's try the next one, print bill, and pass in the bill object we created. And no errors there. You can see right here the bill object adheres to this interface because it has the ID, the amount, and the server, as well as the format method. But if we take off the format method right here, if I comment that out, you might look at this and think, well, it still implements this bill interface because it has all of these properties. But remember, this extends has formatter. So we're essentially saying that this thing has to be here as well. All right. So since we've deleted this format function from this object, now we can't pass it in here because it doesn't satisfy the bill interface. Okay? Alright, cool. So just to finish off then, I'm going to open up the terminal just to see if these work. So first of all, we have this user has an ID of 1 because we pass in the user right here first. Then bill with an ID 2 has £50 paid. That's because we pass in the bill second. Then this right here is all parts of the print bill, which is for this thing over here, server Mario, and then the format function, logging this thing up. Alright, cool, so this all works.